Hello students and welcome back to my channel. We are discussing questions which were asked on the 1st of February 2023 JEE Mains. Okay, in this video we will be discussing questions which were asked on modern physics. So in continuation with other questions, this is question 51 students. A proton having 1/10 of velocity of light has a certain de Broglie wavelength lambda. An alpha particle having certain kinetic energy has the same de Broglie wavelength lambda. The ratio of kinetic energy of proton to that of alpha particle. Now students, it is clearly given that the proton as well as the alpha particle both have the same de Broglie wavelength. And we all know the de Broglie wavelength is given by h by p, where h is the Planck's constant and p is the momentum. So if lambda is same for both, that means what? Which implies p is same for both. And now we have to find the ratio of kinetic energies. As we know, kinetic energy is given by square of momentum upon twice of mass. We all know this. So since p is constant, we can say kinetic energy varies inversely as the mass. Therefore, kinetic energy of proton upon kinetic energy of alpha particle is equal to mass of alpha particle upon mass of proton. Mass of alpha particle is 4 mu, mass of proton is 1 mu. So correct answer is 4:1. Okay students, then moving to the next question. The mass of proton, neutron, helium nucleus are respectively this much, the binding energy of helium nucleus. Now we all know that individually the protons and the neutrons, they combine to form a nucleus. Okay. Now if we consider the individual masses of protons and neutrons, then it will be found that this mass is greater than the mass of the nucleus. For now I take the mass of the nucleus as m. Okay. So the difference in this mass, that is the difference of the mass of nucleons and the mass of nucleus, results in the form of binding energy. That is, the energy equivalent to this difference in mass is equal to the binding energy. So what is the difference in mass? Let us find. So difference in mass will be, so here for a nucleus we have 2 protons and 2 neutrons. So mass of 2 protons, let us say 2 mp, mass of 2 neutrons, let us take 2 ml. So this is the mass of nucleons. So from this mass of nucleon you deduct the mass of helium nucleus. So this gives you mass defect. Let us find mass defect. Once you get mass defect, binding energy will be this mass defect times c square. Okay. Now, so twice into mass of proton. Mass of proton is 1.0073 atomic mass unit. Then similarly, mass of neutron is 1.0087. Okay. Minus mass of helium nucleus is 4.0015 atomic mass unit. So this will be twice into, first let us add this. 3 plus 7 is 5. Then what we call 7 plus 8 is 15, 6, 1, 2.0 minus 4.0015 atomic mass unit. So this will be 4.0320 minus 4.0015. So finally we have 0.0. Okay, 10 minus 5 is 5, 12, 2 minus 1 is 1, 3, this much. This is the end result. Now we know that corresponding to 1 AMU, okay, the energy released will be 931.5 million electron volt. So corresponding to this much mass defect, the energy released or the binding energy will be 0.0315 multiplied by 931.5 million electron volt, because the options are in million electron volt, you can see. Now you can see that 9th is a 27. So slightly more than 27, is it? So that is 28.4. A option is the correct option. So you are not supposed to multiply this. Be careful, students. Kindly don't waste time in multiplying. So as far as possible, try to avoid calculations. Then moving to the next question, the threshold frequency of a metal is F naught. The light of wavelength 2 F naught is incident on the metal plate. The maximum velocity of photoelectrons is V1. When the frequency of incident radiation is increased to 5 F naught, the maximum velocity is V2, ratio of V1 by V2. So this question is based on Einstein's photoelectric equation. So first let us write what is Einstein's photoelectric equation. Einstein's photoelectric equation states that the total energy of the photon, okay, incident on the surface is equal to work function plus the maximum kinetic energy. This is now energy of the photon is h into f, whereas for work function it is h into f naught, and k max is half m v max square. Okay, so therefore we can write half m v max square is equal to h times f minus f naught. So in this way we'll be able to use this. So for the first situation, you can see the velocity is v1 square, v1, and the frequency is 2f naught. So this will be hf naught, equation 1. For the second situation, the maximum speed of photoelectrons is v2, and 5f naught minus f naught is 4f naught. Okay. So when you divide equation 2 by 1, we have v2 by v1 whole square is equal to 4. Therefore, v2 by v1 is equal to 2 is to 1. So we have to find v1 by v2. So 1 is to 2 is the answer. Moving to the next question, an electron of a hydrogen-like atom having Z equal to 4 jumps from 4th energy state to 2nd energy state. The energy released in this process will be. So it's very simple question, student. We know that when an electron jumps from, let us say, n1 equal to 4 to n2 equal to 2, then the energy released is equal to 13.6 into z square if it is hydrogen line, and 1 by 2 square minus 1 by 4 square. This is the formula in electron volt. So the options are already in electron volt, so it's not a problem, student. Okay, right. So this will be 13.6 into z is 4, so 4 square. Here, if you take the LCM, you will have 4 square. This will be 4 minus 1. So this 4 square gets cancelled here. We have 13.6 into 3. So 39. 13 into 3 is 39. So slightly more than 39. That is the option. Then moving to question 55. A photon of energy this much is incident on a hydrogen atom in its ground state. The atom absorbs the radiation and reaches to one of its excited states. The angular momentum of the atom in the excited state. Now we all know that the angular momentum of an electron is n into h by 2 pi. Okay, and the value of h is already given. It's a matter of finding n. That is, to which principal quantum number did the electron rise? Okay, the energy level we have to find. Initially, the hydrogen atom was in ground state, but as soon as it absorbs this energy, it will rise to a different energy state, some higher energy state other than n equal to 1. So we have to find that n and we have to put it to get the answer. Okay. Now we know that the energy required is 13.6 electron volt into from the first orbit. Suppose it moves to the nth orbit. So this formula is valid. Okay. So this is the energy absorbed. So corresponding energy absorbed should be this. So therefore we have 1 upon n square is equal to 13600 upon 275 minus 1 by n square. Sorry, this is 1275. I have multiplied both sides by 100. Okay, this is how we get. This is equal to 1 minus 1 by n square. Therefore, 1 by n square is equal to 1 minus 1275 upon 1360. Okay. So, if we can subtract 1360 minus 1275, so 40 plus 75 is 115. 60 plus 25, sorry, 105. This will be 105 upon 1360. So let us cancel with 5. So 5 2s are 5 1s are 5 2s are 10. Then 5 5 7s are 35. Then 5 2s are 10. Okay. So this will be somewhere close to 21 by 272. To 21 tens are 210. So it will be close to maybe 16, because that is the only perfect square I can see. So n is equal to 4. Okay, n is equal to, because n square is equal to 16, so n is equal to 4. So the required angular momentum will be 4 upon 2 into pi. Pi is 22 by 7. No. We can keep it as pi itself, because the option is, the answer is already in terms of pi. So don't put the value of pi here. So 2 pi into h in electron volt second, it is 4.14 into 10 to the power minus 15 electron volt second. So this will be 2 2s up, then we have 8.28 by pi. Remember, we have to express in 10 power minus 17. So 10 power minus 17 means we have to multiply by 100. So this will become 10 power minus 17. So finally we have 8 to 8. Okay, by pi into 10 to the power minus 17 electron volt second. So answer is 828. Moving to the next question. A nucleus A having Z equal to 17 and equal number of protons and neutrons has this much million electron volt binding energy per neutron. Another nucleus B has Z equal to 12 and total 26 neutrons and this much binding energy per neutron. Difference in binding energies. Now students, binding energy is equal to binding energy per nucleon multiplied by number of nucleons. Number of nucleons is nothing but mass number. So for A, we can have binding energy per nucleon, it is how much? 1.2. So 1.2 million electron volt into since Z is 17 and it has equal number of protons and neutrons, so it should be 17 plus 17, number of protons plus neutrons. So this will somewhere be close to, this is 40.8 million electron volt. Then similarly for B, binding energy for B will be per nucleon is 1.8 and total number of neutrons is 26. So this turns out to be 46.8 million electron volt. So the difference, the required difference in binding energy will be 6 million electron volt. So 6 is the answer. That's all students in this video. Thank you so much for watching my channel.